Hello and welcome to the first video I've made for a few weeks after the sudden rush of videos overviewing the GCSE Maths course which I put up a few weeks ago. Right, in this video we're going a little bit ahead really. We're looking at a subject which is really aimed at A-level students, but if you're a GCSE student who's aiming for maybe an 8 or a 9 or a 7 grade, then this could be of interest to you too. We're trying to have a look in this video about the gradient of a curve. Now, let's start with something we already know, which is the gradient of a straight line. Now, this line here is the line y equals x plus 1. Every point of x here, 1, we go to 2, 3, we go to 4. That's what that line is. Because it's in the form y equals mx plus c, where m equals 1, so we don't really write the 1 in front of the x there. It's kind of taken as read. This is a straight line, because that's the formula of a straight line. And we can just read off what the gradient is, because it's the letter in front of the x. Well, the number in front of the x is 1. So gradient there is 1. It's going up at a steady rate of 1 square up for 1 square along all the way along. Okay, and that was a straight line. So now we're just going to try and extend that idea and just do a bit of revision there to what is a gradient of a curve. Well, the first thing you'll notice is the gradient, the way that it slopes, is different at every point of the curve. That's what makes it a curve rather than a straight line. So how can we actually talk about the gradient if the gradient keeps changing? Well, lots of things in maths keep changing. We can still come up with some sort of idea of what the gradient will be at each point. Over on this side of the on the left side of the diagram, you'll see that it goes from top left to bottom right. So that is actually a negative gradient. Gradient equals minus n. The actual value of n is changing all the time, but we know over this side it's a minus. Over this side is positive, and at the bottom m is 0, because that's where it's parallel with the x-axis. So what can we do to actually work out what the gradient is at each point? Now, what I've drawn on there is a chord. Now, if you're familiar with the circles in GCSE, you'll know that a chord is a line from any point on the circle to another point on the circle. And a tangent is a line which just touches the curve at one point. And then that's going to turn to blue just to draw a tangent, just so we know what a tangent is. So that there is my attempt at writing, drawing the tangent on at the point where x equals 1. I'm just going to get rid of that. I'm just talking about what it is, what the tangent is. And actually what we're going to say, the gradient of the curve at any point is the same as the gradient of the tangent at that point. Now, what I've drawn on there is a chord, not a tangent, and it's between the point. Check I've got my colours on me. Talking about numbers, I'm just going to go back to writing in black. And this point down here is the point 1, 1, and this point here is the point 4, 16, which makes sense. 4 squared equals 16, so that point is on the line. Okay, and the line between the two, we can work out the gradient of that curve. You remember the gradient is basically the change in y divided by the change in x. Well, the change in y is 16 take away 1. That's the change in y is the line goes up for 15 squares there, 16 minus 1. And the change in y is 4 minus 1. So that's 15 over 3, which equals 5. So the gradient of that chord is 5. That doesn't tell us very much about the gradient of the line. But what we can imagine then, I'm now going to change to red and draw a few more lines on. I chose that point. Well, 1, 1 is like my starting point, and that's the point where I'm trying to work out what the gradient is. But the point up here was kind of randomly chosen, and so I'm going to draw in a few more lines to a few more of the points, to there, to there, and you can see as you keep getting closer and closer, so the top point is kind of sliding down the curve towards the point where we're trying to find out the gradient. As you do that and draw curves on, the gradient of these chords is getting closer and closer, well, the chords are getting closer and closer to what will be a tangent at the point 1, 1. So there is a secret there of finding out what the gradient of the curve is at that point. So what we're doing is we're choosing points closer and closer. I could put those red lines back on again. I got rid of them by mistake. Put them back on again. I know how I did that. That's not very well drawn. There and there. So as we're getting the point that we're drawing the chord 2 close and close to 1, 1, that chord is getting closer and closer to being a tangent at 1, 1, and then the gradient of that is the gradient of the curve at that point, 1, 1. So just forget that I really started at 1, 1. Let's kind of think of that now as the point. Oops, let's change my color again and change back to writing. Just think of that as any point x squared. All the points on this graph, on this line, are of the form x squared. So it's 1, 1 is like the one we've drawn on, but just think of it as a general point of x plus 1. And think of the point up here, whichever it is, as x plus a little bit. Now, the little, where we write little bit is that. Now that is a Greek letter called delta. Sometimes you'll see it as a capital letter, used as like a triangle. Never learned Greek, know a few Greek letters by being a mathematician. That is delta x, we call. It's a little bit of x, a little bit more of x. So if we say, we're actually going to make the delta x quite big here, just for the diagram. So that point there is x plus delta x is x plus a little bit more x, and then the y value there is x plus delta x all squared, because that would have to be that to fit on that line. Okay, so what we're going to try and do now is to try and use that formula for the increase in y divided by the increase in x, which is a formula for gradient. We're going to try to apply that to these points here. So the top, what is the change in y? Well, the change in y is that is x squared. The change in y is x plus delta x all squared, take away x squared. That is the difference in the y value, the up value, between there and there. That value, x plus delta x all squared, take away this value, x squared. Okay? And then the bottom is x plus delta x, take away x. Well, those x's can disappear. So then we've got x plus delta x all squared, take away x squared. Now I'm hoping I've left myself a bit enough space here. I might not have done. I'm just multiplying this out now. That's x squared plus 2 times x times delta x. Some of the mathematicians just do a full stop there for multiply, but I'm not. I'm just going to multiply to make it a bit clearer for those of you who are not used to the full stop meaning multiply. We're so used to it meaning a decimal point, it's a bit confusing sometimes. And then plus delta x squared. Or squared. That's just an expansion of that. And then take away x squared and divide the whole thing by delta x. Okay. Now, that's what we've got. But what we're actually going to try and do here, I'm going to introduce a little bit more terminology, which I should probably put up there as well. What we're interested in is this thing here. I've drawn on there that delta x is quite big, so we can see it on the graph. But we actually want delta x to be nothing, because when we actually get to the point where we actually work out the gradient at the point x squared, we want delta x to actually be a tangent. We actually want it to be really drawn to the, infinitesimally close to that line. That's what we want. So what we're going to do is a new notation here. What we do is we limit as delta x tends to 0. That means we want to work out what this thing here is when delta x is, getting closer and closer to 0, if not 0. So actually I should have put that. Sometimes we put just different parentheses around, because that's like a operating on everything inside that square bracket. So we should have done that on that first thing, but I wanted to do the expansion first before I hit you with this limit idea. Okay, and then that is that. Okay, but what have we got inside this bracket? We've got x squared, take away x squared, so they can disappear. Okay, and then we've got delta x at the bottom. Well, the thing is, the trouble with when making that 0 to start with is when you start dividing by 0, you run into difficulty. So let's see if we can remove a delta x from the bottom before we start making it 0, because so we don't cause any problems. And actually, the delta x will cancel with that, so it's just 2x. And then delta x squared divided by delta x is just delta x, so we can sort of get rid of the square bit. So all I've done is I've divided both those terms by what's on the bottom. I've got rid of the x squared, which is good because it had no delta x in it, it would confuse things. And I managed to get rid of the delta x from the other two terms. So what we're left with is the limit, right over here, the limit as delta x tends to 0 of 2x plus delta x. Now we haven't got the problem of the delta x on the bottom. We can make that closer and closer to 0, vanishing the close to 0, until in fact we can forget about it altogether because it's 0 when it actually gets to that point. So it's a bit of a trick, really. We know that with delta x on the bottom, we've run into problems. But once we divide the delta x between the top and the bottom, we can get rid of it, and we end up with this. So that is 2x. And you'll find whenever you draw a tangent to any point to this curve, that the gradient will be twice the x value, because what we found out is that the gradient is 2x. Now I call that, let's just check what I call it. That's differentiation from first principles. Now, there's a lot of words out. The word from is fairly straightforward. First principles means I've done it based on the principles, the first principle, the principle that you understand of how to work out a gradient. Differentiation is a more difficult word to explain, but it's one that if you go into A level, you're going to be using quite a lot. Differentiation just means finding the gradient function. That's what it means. Underneath I'll put a link to. I've actually linked on my website to a really useful site that differentiates all sorts of things. There's all sorts of different well, there's two specific notations. So there's lots. There's two specific notations that were invented by two different mathematicians, Isaac Newton and Gottfried Leibniz. And one of them worked out one, and the other worked out the other. And I must admit, it doesn't matter now which is which. But no matter that I looked up beforehand. This is one way of writing it. If we're talking function notation, f of x equals x squared, we write it that equals 2x. What it means is, if the function is x squared, then at every point the gradient function is 2x. Now, every function, like for example fx equals cosine x. And I sometimes get this the wrong way around, so let's just check. I believe that is minus sine x. And I could have done the first principle stuff with all of this stuff, but this calculation here works out differently when you start to work at cosines and sines. And I have to do a little bit more A-level playing around with cosines and sines with you to actually show that. But if you think about the curve, draw the curves on a piece of paper, you'll see that as the cosine leaves naught, it starts coming down, the gradient is negative, and that is actually worked out by sine x. And when you get to A-level, you'll actually learn lots of different put that bit in there, lots of different functions and what their differentiation is. But I'm not going there. This video was just to show you how you can work it out for x squared. I'm not listing any more in this video. I'll do some more videos on A-level math sometimes. And but if you want to go and follow the link to the website, both on my website and which I'll put under this video, you'll see you can put any function in, and it will give you the gradient function. And when you get into A-level, you'll become good at doing those yourself. Okay, that's the end of this video. Thank you very much for watching. And my differentiation from first principles video. And I'm going to stop the video now. Thank you.